from the unsupervised learning, and here we'd like to talk about one of the things that we do with the unsupervised learning, which is the clustering. So by the end of this part, we'll be understanding like what is clustering, what are the common applications of clustering, the different methods of clustering. We'll not cover the implementation in Python, and we'll talk a little bit about the advantages and limitations of the clustering. Now, clustering, we said in any unsupervised learning, we're trying to discover the similarities between the entities, the different samples that does not have an output, we don't have a label. Yeah. Now in the clustering, so we're trying to gather data records in its groups. We would like to have some kind of natural groups, clusters of the similar samples according to some predefined similarity or dissimilarity metrics. And this results in extracting a set of useful information about the data set. The content of any cluster should be similar to each other. So when you decide a group, in the group itself, they have to be similar to each other with what's called the inter-cluster similarity. And each group has to be so different from the other group with what's called the inter-cluster separation. Now, the similarity and the dissimilarity metric is routinely utilized in clustering analysis, and it's a form of distance function between each pair of data requests. Therefore, the distance measures of how close point A to B and from each other, and the decision is made whether to combine A and B in one group, another cluster, or not. Now, two commonly implemented simple forms for the distance function, since we're talking about mathematics, yeah? So we're defining two groups, and we'd like to find how each group is similar to each other, and how the group is so far from the other group. So this in mathematics is basically measuring distances. And how we do that is really by what's called the Euclidean distance or the Manhattan distance. Yeah. In the Euclidean distance, what you're doing is like finding two-dimensional data sets that having, for example, two features, then you combine or you compute the distance between them. If you have it in 2D, then you have it in the X and Y, and you find the difference between the X's squared and the Y's squared under the square root, then you find this distance. Whereas the Manhattan is the absolute difference between the X dimension and the Y dimension. These two distances, why do we need them? It depends on different applications. So if we're talking that you're designing a robotic arm, that would like to pick up an object from a table and then move it to a specific location. Then you have to install different sensors on the arm to measure the distance, the position, the orientation of the arm relative to the objective on the table. And you would like to calculate the distance between the two objects in the two-dimensional space based on the sensor measurements. So if you have like the original location was 3, 2 in the X and Y, plane, and the other object is really at -1 and 5. How can we compute the Euclidean distance and the Manhattan distance? The Euclidean distance, we said it will be the X dimensions, the difference between them squared plus the Y dimension squared under the square root, and then we get it as 5 minutes. This metric will help us actually to find the distances between different objects in the robotic workspace application. And can be used for object detection, localization, and or in the manipulation. However, if you like to find the Manhattan distance, it will be 7 units. I hope you can try it. And this metric will define you the minimum number of steps that the robot will take in order to reach the target, and will go into Manhattan blocks, yeah, location. And it will only like moving in horizontal and in a vertical movement, without being able to move in a diagonal movement. And this is the difference between the Euclidean, which goes diagonally, and the Manhattan, which can go only horizontally or vertically. This metric can help us to plan the movements in a grid-like environment, like for obstacles, and can be useful in different applications such as navigation, path planning, obstacle avoidance. We learn Now, one of the clustering techniques, which is the centroid clustering method, and in the centroid, basically from its name, we'll try to group points in a center and then find the distances from that. This basic technique, or it's known as the K-means clustering, which is a centroid-based clustering approach that can be used actually a lot in different applications, and it's one of the predetermined number of clusters, the way it works. It always searches for a predetermined number of clusters within unlabeled and possibly multidimensional data set. Now, the approach actually consists of three main steps: initialization, assignment, and updating step. But we'll go to the example to explain that in the easiest way. So if we have an example of points that we can see here, we're interested, like we have two features, the x and y, as you can see. So we have the x dimension and the y dimension. This is what I can. Yeah. We have these points here, as you can see, and we can the way we work is firstly is that we define randomly one of the points uh, uh, as a center for specific cluster. So the first step is that whenever you have a data set, you must define how many groups you would like to have. Let's say in this example, we decided a simple example. We can look at the data immediately, but in any real life example can be more complicated. You cannot really define it immediately, but still, like in this one, just for explanation, we have the group. As you can see, we can define that we'd like to have three groups. According to that, we can define three centers. Now, the way to define it, either you define it out of random, or you take one of the points also out of random to say that I would like to have this as a center, another one as a center, and another one as a center. So here I chose like the three centers C0 and C1 and C2, as you can see in the